I hope you enjoying the holiday, and today I will start your the next topic, carboxylic acid. Okay, and in this chapter we will discuss about the first of all the introduction of carboxylic acid, and after that I will discuss the structure of carboxylic acid and then method of preparation of carboxylic acid and then chemical properties of carboxylic acid. So get on the topic. Yes, it is your the carboxylic acid chapter number 12, and this topic is for the class 10th class. Okay, and your topic is carboxylic acid. Which topic? Carboxylic acid. And you know very well, carboxylic acid are the found in the many substances, and you heard the like acetic acid found in the vinegar, and the ascorbic acid found in the mangoes. Okay, and lots of the acid are found in the organic substances, means the plants as well as animal. Okay, for example, it is what? Grapes, and the grapes contains the tartaric acid, and the lemon contains the citric acid, spinach oxalic acid. Okay, so first of all we will discuss about the carboxylic acid. You know very well, carboxylic acid is a organic compound. Which type of compound? Organic compound. It is organic compound. Clear? The general formula of the carboxylic acid are COOH, and COOH you can represent in this the form R C double bond O single OH. And why it is called the carboxyl group? Because of the it contains carbonyl group as well as hydroxy group. That's why called carboxyl group. Okay, and it is a hydroxy group, and CO, this group is called carbonyl group. And the general formula of the carboxylic acid is RCOOH. Okay, and also you can represent in this way RC double bond OH, and the general formula of the carboxylic acid CN H2N plus 1 single bond C double OH. When you will put the N is equals to 0, then HC double OH. When you will put the N is equals to 1, then you will get a CS3 C double OH. Similarly, when you put the N is equals to 2, then you will get a CS3 CS2 C double OH. Okay, and it is what? HC double OH. HC double OH is called formic acid, and the CS3 C double OH is called acetic acid, and the CS3 CS2 C double OH is called propanoic acid. Clear everyone? And there are the two names of the carboxylic acid. One is the common name and the second is IUPAC name. And the common name of this compound is called formic acid, whereas the IUPAC name, it contains the one carbon, then the word root used for the one carbon meth and single bond N, and the secondary suffix for the COOH group OIC acid, means that it is what? methanoic acid, and it is what? Ethanoic acid, and it is what? It contains the 3 carbon, that's why called propanoic acid. Okay, and get on the next topic, types of the carboxylic acid. Types of carboxylic acid based on the number of COOH group, it categorized into the 3 groups. First, the monocarboxylic acid, second, dicarboxylic acid, and the third, tricarboxylic acid. If acid contains the single COOH, then it is said to be the monocarboxylic acid. And if contains the 2 COOH, then it is said to be the dicarboxylic acid. And when it contains the 3 COOH, then it is said to be the tricarboxylic acid. Yes, nomenclature of the carboxylic acid. There are the, I have discussed in the previous slide. Okay, nomenclature of the carboxylic acid, common name, and the second is IUPAC name. Common name, this name derived from the name of the source from which they were isolated. For example, you know very well acetic acid. Acetic acid found in vinegar. Vinegar means acetum. That's why called its name acetic acid. And the formic acid contains the from the formica, and the formica means red ant. And get on the IUPAC name, and the IUPAC name of the carboxylic acid in the form of alkanoic acid. Alk means the number of carbon, N means the single bond, and the OIC acid is a secondary suffix for the carboxylic acid. That's why it is what? It is contain the 1 carbon, that's why called methanoic acid. It contains 2 carbon, that's why ethanoic acid. And it is contain 1, 2, 3 carbon, that's why propanoic acid. Similarly, 1, 2, 3, 4, it is what? Butanoic acid. Yes. Your next topic is a classification of carboxylic acid. When carboxylic acid contains the 1 COOH group, then is said to be the monocarboxylic acid. Okay, and it is what? All are the what? All are the monocarboxylic acid. Monocarboxylic acid, because of it contains the single COOH. Acetic methanoic acid, ethanoic acid, propanoic acid, butanoic acid, all are the contains the only 1 COOH. That's why it considered in the monocarboxylic acid. And get on the dicarboxylic acid. Dicarboxylic acid means when contains the 2 COOH group, then is said to be the dicarboxylic acid. For example, oxalic acid. What? Oxalic acid. And oxalic acid found in spinach, tomato, oxalis plant. Okay, and it is a structure of the oxalic acid, and this compound contains the 2 COOH. That's why considered in the dicarboxylic acid. And the common name of this compound is oxalic acid. Common name oxalic acid, and IUPAC name 1, numbering 1 and 2. 2 carbon, that's why it, and 2 COOH group, 1, 2 dioic acid. N used for the single bond. Clear? And next, it is also dicarboxylic acid, COOH, COOH. It also contains the 2COOH group. That's why called dicarboxylic acid. And IUPAC name 1,2,3 propane 1,3-dioic acid. And common name of this compound is called myelonic acid. What? Myelonic acid. It is what? Oxalic acid, and it is what? Myelonic acid. And it is what? It is succinic acid, and it contains the 1, 2, 3, 4. 1, 2, 3, 4. If the carboxylic acid contains the 4 carbon with the 2COOH functional group at a 1 and 4 position. Which position? 1 and 4. Then is said to be the succinic acid. And the IUPAC name of this compound, butane 1,4-dioic acid, because of the COOH group present at the 1 and 4 position. Got it, everyone? Next, yes, dicarboxylic acid. And next is your tricarboxylic acid. Tricarboxylic acid. Tricarboxylic acid. If acid contains the 3COOH, then is said to be the tricarboxylic acid. For example, COOH, CH, COOH, CH2, COOH. It contains how many COOH? 3. That's why called considered in the tricarboxylic acid. 1, 2, 3, 4 and the 5. So what is the name of this compound? IUPAC name? Pent 1, 2, 3, 4, 5 and N dash 1, 3, 5 trioic acid. Okay, so how many the types of the carboxylic acid? If 1 COOH present, then is said to be the mono. If 2 COOH group present, then is said to be the di. And if the 3 COOH group, then is said to be the tricarboxylic acid. Get on the next topic. Structure of the carboxylic acid. You know very well, acid contains the COOH functional group, and it is about COOH functional group. You know very well what is the functional group. Functional group is a part of organic compound which describe the chemical property of the compound. Okay, and it is a functional group. It describes the chemical properties of compound. You can represent COOH in this form: single bond C, double bond O, single OH. Okay, and you can represent in this way also: single C, double bond O, single O and H. And O contains the 2 lone pair, and the bond angle of COOH is 120, means the trigonal, and the bond angle is the 120, and overall angle 360, 120, 120 and 120. Clear, everyone? So it is about structure of the carboxylic acid. Next topic is your Next topic is your method of preparation of the carboxylic acid. And the carboxylic, especially we will discuss about the method of preparation of acetic acid. First, from the ethyl alcohol. From ethyl alcohol, you know very well the formula of ethyl alcohol is a what? CH3CH2OH. Okay, acetic acid is obtained. Acetic acid is obtained from the fruit cider. Okay, from the fruit cider. For example, grapes, mango, amla. Okay, and the ethyl alcohol is prepared by the fermentation of the fruit cider containing the sugar. Means here is the mistake, means the here carboxylic acid. Means carboxylic acid is prepared by the fermentation of fruit cider containing sugar. For example, it is what? Ethyl alcohol. When the ethyl alcohol oxidized in the presence of platinum catalyst at a 300 degrees Celsius, then ethyl alcohol convert into the ethanoic acid, and the ethyl alcohol contains the 1 carbon and the 2 carbon, and ethanoic acid also contains the 1 carbon and the 2 carbon. So clear everyone? And the next method is your by oxidation of alcohol. By oxidation of alcohol, you know very well oxidation means addition of oxygen and the removal of hydrogen, and in the presence of the oxidizing agent. Okay, clear? Oxidation. On oxidation of alcohol, it will give the first aldehyde, and the aldehyde further converted into the carboxylic acid. So you can say directly ethanol is converted into the ethanoic acid in the presence of oxidizing agent. It is what? Potassium permanganate, camenophore, and it is K2Cr2O7. It is potassium dichromate. Both are the oxidizing agent, means a strong oxidizing agent, means without this oxidizing agent you cannot ethanol converted into the acetic acid. Means the oxidation of alcohol always occur in the presence of oxidizing agent. Yes, get on next topic. What is glacial acetic acid? What is glacial acetic acid? The anhydrous acetic acid on cooling up to the 17 degrees Celsius. When you will cool the acetic acid on the at a 17 degrees Celsius, then it will forms an ice-like mass floating at the surface, giving it an appearance of the glacier. That's why pure anhydrous acetic acid often called the glacial acid. Okay, when anhydrous acetic acid cooling at a 17 degrees Celsius, then it will form an ice-like structure, means a mass which is floating at the surface and giving it an appearance of look like a glacier. That's why called it is glacial acetic acid. Okay. Yes. So next topic is your ethanoic acid. And what is ethanoic acid? I have discussed in the previous slide. It is one of the naturally occurring acid. Ethanoic acid are found in acetic acid, means the acetum, vinegar. Okay, that's why called naturally occurring acid. And it is a second member of the carboxylic acid. Ethanoic acid, why it is called ethanoic acid? Because of the it contains the two carbon, that's why called eth. That's why also said the it is a second member of the carboxylic acid, and it is a structure of the ethanoic acid CH3 single bond C double bond OOH. Okay, and the 4 to 5% solution, 4 to 5% solution of ethanoic acid is called vinegar, and it is used, vinegar, it is used for the flavoring or the preserving food. Okay, means the ethanoic acid is also used as a for the flavoring and for the preserving the food. Got it, everyone? And the next we will discuss about the physical property of carboxylic acid and the chemical properties of carboxylic acid. To get on the first physical properties of ethanoic acid. Ethanoic acid is a colorless liquid. It is a colorless liquid, corrosive in nature, and it have a pungent smell, sour taste, and its melting point 17 degrees Celsius, BP boiling point 118 degrees Celsius. Okay, and it is a nature hygroscopic. Its nature is a hydroscopic in nature. Okay, and also it soluble in water. Carboxylic acid easily soluble in water and also dissolve in the soluble or dissolve in the organic solvent like alcohol, ether. Clear, everyone? And always keep in mind, carboxylic acid always in the solution exists in the form of dimer. Di means two and mer means part, means the two part of the carboxylic acid, and by the process of dimerization. Clear, everyone? Means carboxylic acid exists in the dimer form in the solution. The two carboxylic acid combine to form the dimer by the hydrogen bonding. Okay. Next topic is your chemical properties of ethanoic acid. Acetic acid ionizes an aqueous solution and shows all the properties of an acid. You know very well, all acid give the hydrogen ion in the aqueous solution. When any acid dissolve in the water, then it will dissociate and it will produces a hydrogen ion. And hydrogen ion, due to the hydrogen ion, it shows the all the properties of an acid. For example, it is what? Acetic acid. It is what? Acetic acid CH3 C double OH. And the IPSC name of acetic acid is ethanoic acid. When dissolved in the water, then it will produce a hydrogen ion and plus CH3 C double O. It is what? Acetate ion. Because of the it's produces from the acetic acid, that's why called acetate ion, and it is a anion and it is a what? Cation. And this cation, hydrogen combined with the water, then it will form the hydronium ion. It is what? Hydronium ion. Because of hydrogen ion, when combined with the water molecule, then it will form the hydronium ion. You know very well, all acid give the H plus means the hydrogen ion in the aqueous solution. Ethanoic acid is a weak acid because of it is a organic acid, and this acid is edible in nature, means you can eat ethanoic acid. And ethanoic acid convert the blue litmus paper to the into red litmus paper. This shows the what acetic acid is acidic in nature. Acidic in nature. It react with the metal. Ethanoic acid react with the metal, especially zinc and the magnesium, and evolve the hydrogen gas. You know very well, when the any acid react with the metal, then it will form the salt and releases the hydrogen gas. For example, it is what acid react with the zinc or magnesium, means the metal, then it will form what? Magnesium acetate. What? Magnesium acetate. It is a type of a salt, and hydrogen gas releases. Get on the fourth reaction. This reaction is called neutralization reaction, and you have learned in the chapter metal and non-metal. Okay, acid. When acid react with the base, then it will form salt and water. For example, it is what? Acetic acid. When acetic acid react with the base NaOH, then it will form CH3COONA plus H2O, and it is what? Sodium acetate and salt, and this is what? Water, and water as a byproduct. Okay, so when acid react with the base, then it will form salt and water, and this reaction is called neutralization reaction. Why it is called the neutralization reaction? Because of the base neutralizes the effect of acid, that's why called neutralization reaction. And the next reaction is your reaction with the metallic carbonate and the hydrogen carbonate. When acid react with the metallic carbonate or the hydrogen carbonate, then it will form the water salt, and also it will form the water and also form the carbon dioxide, and the carbon dioxide and the water is considered as a byproduct, but main product is your salt, means the sodium acetate. Clear everyone? When acid react with the metallic carbonate, means the sodium carbonate Na2CO3 or NaSCO3, then it will form sodium acetate plus carbon dioxide and plus water. Get on the next reaction. Next reaction is your esterification. Get on the next reaction, esterification. Okay, and it is also very important reaction for exam point of view. Okay, when acid react with the alcohol, in the presence of concentrated H2SO4, and here concentrated H2SO4 act as a dehydrating agent. Which type of agent? Dehydrating agent. This agent remove the water molecules from the acid and alcohol when it will mix. Okay, CH3 COOH and plus it is what? Alcohol. It is what? Alcohol CH3, CH2, OH, and the H of acid and OH of alcohol combined, and it will form CH3, C double bond O, and this O combined with the CH2, CH3, CH2, CH3, and remove the H2O. It is what? Ethyl ethanoate, and it is what? Ester. It is what? Ester. When carboxylic acid react with the alcohol in the presence of concentrated H2SO4, then it will form the ester and water. That's why called the esterification. The main product of this reaction is a ester. That's why called esterification. Clear everywhere? Next topic is your dehydration of acetic acid. Dehydration means, D means removal and hydration means water. Means the removal of water molecule from the acetic acid. Okay? And the P2O5, one is your concentrated H2SO4, so 4 is also dehydrating agent, and the P2O5, it is what? Phosphorus pentoxide. Phosphorus pentoxide, it is also considered as a dehydrating agent, and this agent, dehydrating agent, remove the water molecule from the acid. Okay, CH3COOH, and I have taken the 2 moles of the ethanoic acid, CH3COOH, CH3COOH. It is treated in the presence of dehydrating agent P2O5, then it will form the acetic anhydride. It is what? Acetic anhydride, and plus byproduct is what? Water. And from the 2 moles of the carboxylic acid, means the ethanoic acid, 1 H removed from this compound, and the OH removed from this compound, and finally combined, then it will form the H2O, and it will give the what? Acetic anhydride. And you can represent acetic anhydride in this form also, because of the CH3CO twice, CH3CO twice, and the single oxygen. Clear everyone? And it is a what? Which type of reaction? Means the dehydration reaction. Which type of reaction? Dehydration. Dehydration means removal of water molecule from the acetic acid in the presence of dehydrating agent. And for this, P2O5 is considered as dehydrating agent. Concentrated H2SO4 is also considered as a dehydrating agent. Both reagents removes the water molecule from the acid. Okay? And the next reaction is your reduction of acetic acid. Reduction means oxidation means, I have told you many times, oxidation means addition of oxygen and the removal of hydrogen. But reduction means addition of hydrogen and the removal of oxygen. And always reduction reaction always occur in the presence of the reducing agent. And the reduction process represented by the nascent H. And it is what? RCOOH, it is what? Acid. And when on reduction of acid, and it is LiLH4, lithium aluminum hydride, and it is what? Sodium borohydride, and both are considered as reducing agent. And on reduction of acetic acid in the presence of LiLH4 or NaBH4, then first it will convert into the RCHO, and further on reduction of the aldehyde, then it will converted into the alcohol. You know very well, On oxidation of alcohol converted into aldehyde, and the aldehyde converted into further carboxylic acid. Similarly, reduction of the carboxylic acid, first it will give the convert into aldehyde, and then further converted into alcohol. Because of the oxidation process, means the reduction process is the opposite of oxidation reaction. It is what? Acetic acid. IUPAC name ethanoic acid. On reduction of the ethanoic acid in the presence of lithium aluminum hydride, first if converted into ethanol. What? Ethanol, and the common name is what? Acetaldehyde. And further on reduction in the presence of LiLH4, then it will converted into CS3 CH2OH, and it is what? Ethyl alcohol. It is what? Ethyl alcohol, and also called, it is also called ethanol. Means ethanol is a IUPAC name of ethyl alcohol. Ethyl alcohol. Clear everyone? And get on the next reaction with PCl5. Reaction with PCl5. PCl5 means the phosphorus pentachloride. What? Phosphorus pentachloride. When acetic acid react with the PCl5, then it will give the what? CH3COCl, acetyl chloride. It is what? Acetyl chloride, or you can say acyl chloride. Acyl chloride, because of it, this group is what? Acetyl group or acyl group. That's why I called acetyl chloride or the acyl chloride. And the byproduct is your phosphoryl chloride and the HCl. And you know very well structure of the PCl5, PCl and 3Cl. 3Cl are present in the one plane, and the 2Cl are present in another plane. That's why first of all, when the PCl5 on the dissociation of the PCl5, first of all break the two bond, means the 2Cl, means it will give the PCl3 and the 2Cl minus. Okay, and the 1Cl attached from C double bond O, and the second Cl is mixed, add with the hydrogen, it will form the HCl, and the oxygen combined with the PCl3, then it will form the phosphoryl chloride POCl3. Clear everyone? Means the when acetic acid react with the PCl5 or PCl3, then it will form the acetyl chloride or acyl chloride, and acyl chloride is a major product, and this is a what? Both are the byproduct of this reaction. And the next topic is your decarboxylation. And D means removal. D means what? Removal, means the removal of the carbon dioxide CO2 from the carboxylic acid. This reaction is called what? Decarboxylation. Removal of the carbon dioxide from the carboxylic acid by heating is called decarboxylation. And decarboxylation reaction always occur in the presence of soda lime. And the soda lime is a what? Soda lime is a mixture of NaOH and the calcium oxide in the 3:1. 3:1 means the when sodium hydroxide and the calcium hydroxide mix in the ratio of the 3:1, then it will form, this mixture is called what? Soda lime. Means the acetic acid. When acetic acid react with the base in the presence of calcium oxide, then it will form what? Then it will form sodium acetate. What? Sodium acetate. Okay? Not in the presence of calcium oxide. Okay? It is what? Acetic acid. When acetic acid is treated with base in the presence, not in the presence of calcium oxide, then it will form the what? Sodium acetate, and it is a salt. It is a what? Salt, and it is a water. And when sodium acetate is treated with a base NaOH in the presence of calcium oxide, then it will form the what? Methane gas. And the releases of what? And the Na2CO3. Okay? This CH3 and H combined form the CH4 methane gas, and thus Na2Na combined with the COO and this O, then it will form the Na2CO3. This reaction is called the decarboxylation. Means the removal of carbon dioxide from the carboxylic acid on heating in the presence of soda lime, and it will give the what? Methane gas, and the byproduct the sodium carbonate. And it is a very important, soda lime is a what? Mixture of the NaOH and the calcium oxide in the ratio of 3:1. And the last topic is your uses of acetic acid. You know very well uses of the acetic acid. White vinegar, it used as a food preservative. You heard the acetic acid used in the preservation for the pickles. Okay? And the second, cellulose acetic acid and the polyvinyl acetate, which are used for the making synthetic fiber. Means the acetic acid also used for the making of the synthetic fiber. And ethanoic acid or the acetic acid also used as a laboratory reagent. You know very well that ethanoic acid is a what? Chemical substance. Means the chemical, it is a type of a chemical acid. Okay? So I hope you understand all the topic carboxylic acid. Okay? And next time we will discuss the next chapter. Okay.